Here you see again what you just saw in the written description of this particular concept. You see the equation that we were attempting to graph, and we see the fairly confusing to look at finished graph. So I wanted to create a video for you so that you could actually see where this picture comes from as the final, to give us the final graph. And of course, because we can use different color, you can put them all on the same set of axes. It's done for reasons other than that as well, as we'll talk about. Now, the title of this is Graphing by Addition of Ordinates. What does that mean? What does that word ordinate mean? Well, somewhere back in your memory, hopefully, of discussions about the coordinate plane, and in particular discussions about this ordered pair that we usually represent with x and y. In the writing that we had in the book that you used, and several books that you've used to this point, there was some language associated with this set of coordinates that we tended to not make you accountable for, but it is part of the language and it's important. We told you in the writing that this first coordinate, the x coordinate, is called the abscissa. And I think I hear some bells ringing out there in cyberspace, as some of you do remember that word, and that the y coordinate had the name of ordinate. Now, the fact that we know what an ordinate is means that we must be graphing this finished equation by adding the y coordinates of some other equations, and that's what this graph is supposed to indicate to you, but it doesn't do a very good job. So I want to try and correct that for you. So in the written discussion, we started out by saying that if we look at this equation that we want to graph as being these two simpler graphs added together, then this final equation, we're coming up with its actual path, this blue path, by adding the y coordinates on these two graphs. Now let me break that down a little further for you. So to begin with, here you see the graph of y equals cosine x all by itself. Now here you see we've added y equals 2 sine x to the graph, and to actually do the addition then that our actual equation is requiring, what we do is, well, first of all, look at the intercepts, and as long as the intercepts are on the any point that has an x-intercept means that of the two equations that we're adding, the y coordinate that isn't 0 is the one that's not going to change. So our first point is going to be about there where our y value is 1. Okay, here we have a point where both graphs, or the two graphs, intersect. So it's meaning that we're going to add this distance to itself to get a new y coordinate that's going to be about here. Then we also know that we've got another x-intercept there, right here at the peak, and through this section we actually have y values that are on the positive side of the x-axis. So we know that these two are going to add together. So how do we do that? Well, what I would say is, and you're doing this with pencil as opposed to what I'm doing, but I would say, you know that for any x value we're adding the two y coordinates, and if we measure the lowest one and then take that and add it to the highest one, then our y-coordinate should be there. And if we do that repeatedly, then we'll find where we actually have the maximum in there, and then we just have to begin to connect the curve. And I'm going to say that point that I just plotted isn't very accurate, so let's take it out. So then from there, let's change instruments. From there then, it's just a matter of beginning to connect the dots with a smooth curve. Now we could do it more accurately. We could actually find the y-coordinate on each of those curves. I didn't want to do that. We could find the y-coordinate on each of the curves and numerically add them together. But most of the time when we're graphing by ordinates, we're just looking for a sketch, and accuracy isn't quite as important in a sketch. I mean detailed accuracy. So again, by doing this process, then we end up with our final curve. And here again you see the completed product of adding our ordinates.